In this video, we're given the function f of x equals sine of x plus 2x, and we want to find the tangent line to the inverse of f of x at x equals pi. Actually, it's going to be 2 pi. Let's make that x equals 2 pi. Pi would be a much harder question. So first, whenever we're talking about inverses, the idea is you want to think flip the x's and y's. Now, right now we don't have any y's, but we can, introduce them. We can start with y equals sine of x plus 2x. And then we're going to flip over to x equals sine of y plus 2y. Just as a small note, this equation represents y equals f of x. This equation represents y equals g of x. So these are two different things. And now that we've found this equation here, I do not need the first equation at all. So I'm just going to scribble it out. I'm not going to use it in the rest of my work. So we have x equals sine of y plus 2y. I want to find y prime. So y prime, to find that, I'm going to use implicit differentiation. The derivative of x is 1. The derivative of sine of y is going to be cosine of y times y prime plus 2y prime. I need to factor out a y prime, so I'll have 1 equals y prime cosine of y plus 2. We'll end up with y prime equals 1 over cosine of y plus 2. So that's all fine and good. We have the derivative. Remember that we're actually trying to find a tangent line. So the tangent line is going to be given by L of x equals f prime, or I'll write y prime of x, or y prime of a times x minus a plus y of a. Or you might see it as y minus y naught equals m times x minus x naught. And we could use either of those formulas. I'm going to use this one just for fun. In order to find my slope, I'm going to need to find what's y prime when x equals 2 pi. Well, I have y prime in terms of y, not x. So I'm going to need to find out what x equals. And to do that, we can look at this, we're going to need to find out what y equals when x equals 2 pi. And a nice equation that might help us out here is this equation we started with. It tells us that x equals sine of y plus 2y. So what I'm looking for is where does 2 pi equal sine of y plus 2y? And you might need to do a little bit of guessing here. You might try some exact values, and if you guess enough, you can't actually solve for y here, but it turns out that y equals pi will do the job. Because you plug in pi, you'll get sine of pi, which is 0, plus 2 times pi, which is 2 pi. So that works. So that tells me that y prime at when x equals 2 pi is going to equal 1 over cosine of pi plus 2, which is going to equal 1 over negative 1 plus 2, which equals 1. So I have my slope is 1. So this is 1. And we also need an x-coordinate and a y-coordinate. My x-coordinate was 2 pi. We were told that initially. And the y-coordinate, which I had to do some work later to find, was pi. So my tangent line is going to be y minus pi equals 1 times x minus 2 pi. That's the same as y minus pi equals x minus 2 pi, or y equals x minus pi. So I found my tangent line, and that's all there is to the problem. So there's a couple ways to think about this. I think that getting to this point where you have x equals sine of y plus 2y, and recognizing this is the equation you really want to be working with for the rest of the problem, is probably one of the more helpful ways to think about it. So there you go. There's a way to find the tangent line to the inverse of a function.